Bismillahirrahmanirrahim. Today we are going to speak about a system of linear equations in two variables. First of all, let's define the meaning of the system of equations. Usually we are saying that system of equations is two or more equations. So you can think about two equations or more considered together. It means that we are solving two equations or more equations to find a common solution for both of them, for the first equation or the second equation. For example, this system, which is given by 2x plus 3y equal to 4, and 3x minus 2y equal to minus 7, is a system of linear equations. And we have two variables, x and y. And that's why we call it a system of linear equations in two variables. Each equation is a linear equation. So 2x plus 3y equal to 4 and 3x minus 2y equal to minus 7. These are two equations. If we consider them together, we have a linear system or a system of linear equations. Now, if we consider the equations separately, if I take the first equation, 2x plus 3y equal to 4, this is a linear equation, and it has infinite number of solutions. Let me take the first equation, 2x plus 3y equal to 4. Let's try to sketch this equation. It is linear equation. It means we must have a line. And to graph this one, we can use the x-intercept and y-intercept. 2 points are enough. If x equal to 0, then y will be 4 over 3. If y equal to 0, then it is 2. So I have 0 and 4 over 3. So it is about 1/3. This is 1 point. And 2 and 0. Let's say this is 2 and 0. So this is the equation of this line, or the line of this equation, which is 2x plus 3y equal to 4. Now for the second equation, which is 3x minus 2y equal to minus 7. You can see, since we have a line, so any point in this line is a solution for the first equation, any point. So we have infinite number of solutions. For the second equation, I have 3x minus 2y equal to minus 7. If you want to graph this line in the same xy plane, using also the x-intercept, y-intercept for this one, when x equal to 0, I will have 7 over 2. If y equal to 0, it will be minus 7 over 3. So I have 2 points, 0 and 7 over 2, which is about 3.5. And the second one is minus 3 over, or minus 7 over 3. This is minus . Which is about 2 point something it is at this point. And if we connect the 2 points, I will have a line. Now the intersection point, or the intersecting point, this one will be the solution of the system. So we can see that. If we consider the equation separately, each equation has infinite number of solutions. Each equation in two variables has infinite number of solutions. But if we consider them together, then we'll have a common solution. So we can say a solution of a system of equation in two variables is an ordered pair that is a solution of both equations. It is this point, the intersecting point. So we are looking for an ordered pair that satisfy the two equations, the first equation and the second equation. We are looking for a value for x and value for y that will satisfy the first equation and the second equation, or we can say it is common solution for both equations. So from this graph, in some cases we have one intersecting point that will be the solution of the system. But since we said that the two equations will give me two lines and the solution of the system will be intersecting point, we have three different cases. Sometimes we'll have a system of equation is a consistent system if it has at least one solution. In some cases, we have one intersecting point. If the two lines of the two equations are intersecting in one point, then we call that system consistent system. It means it has a solution. Consistent system means it has a solution. And that solution might be one intersecting point, or it might be infinite number of intersecting points. A system of equation with no solution is called an inconsistent system. It means it has no solution, or the solution set equal to 5. So we should know these type of systems. Consistent system if it has at least one solution, and inconsistent if it has no solution or the two lines are not intersecting. A system of linear equation with exactly one solution, if it has only one solution, is called an independent system, similar to this one. So this system has one intersecting point. Single point, exactly one solution. It is this one. This system, we call it dependent or independent system. It has exactly one solution. So it is independent system. If it is independent, means it has only one solution, or the two lines are intersecting in one point. A system of linear systems equation with an infinite number of solution is called dependent system. It is this one. The two equations will give me the same line. The two lines are coincide. They have the same line. So the first equation will give me this line. The second equation also will give me the same line. So each point on that line is a solution for the system. So we say it is infinite number, or it has infinite number of solutions. And in this case, we call it is consistent but dependent. It is not independent. So we have consistent with one solution that is independent. And we have consistent but dependent that has infinite number of solutions. The third type, if the two lines are parallel, they are not intersecting. If the two lines are parallel, means there is no solution. The first equation has a solution different from the second one, or there is no common solution between the first one and the second one. So the two lines are not intersecting, they are parallel. If they are parallel, we say this is inconsistent system. It means no solution. So again, we have consistent system with one solution, that is independent system. And we have consistent with infinite number of solutions, that is dependent system. And we have inconsistent system with no solution, or the two lines are parallel. They are not intersecting. So this will be the three types of system that we are going to discuss, and to find the solution for system if it has, and to say whether it is consistent or inconsistent, and also to say whether it is dependent, if it is consistent, or independent. That will be explained in the second part of this topic.